Hello guys, this is part 64 of SQL Server video series. In this video we will discuss about replacing cursors using joins. In part 63 we have discussed about cursors. The example in part 63 took around 1 minute 40 seconds on my machine to complete. If you have not watched part 63, I would strongly encourage you to do so before proceeding with this session. In this video, we will discuss about rewriting the same example using a join. So if you remember, in part 63, we updated unit price TBL product sales table to 55 when the product name is product 55. If the product name is product 65, if the product name is product 65, then we updated the unit price to 65. On the other hand, if the product name starts with product 100, we updated the unit price to 1000. Let's see how to achieve the same thing using join and see how fast that query will be. So what do we want to do? We want to update TBL product sales. We want to update TBL product sales table. Within that, we want to update unit price. We want to update the unit price. Set unit price is equal to, I'm going to use the case statement here, but we will come to that in just a bit. First, let's specify the table. So in the from class, we specify product sales table. So I want to update TBL product sales, and same from TBL product sales. And to find out the name is not present in TBL product sales table. It is present in TBL products table. So I have to join with TBL product table and specify the join condition. What is the column between and specify the join condition. What is the column between the two tables in TBL products? The column is ID, and within TBL product sales it is product ID. and product TBL in table TBL products, the column is ID, and in TBL product sales, the column is product ID. So that is the common column. So that is the common column between these two tables, TBL products table and TBL product sales table, based on which we are joining them. And look at this. So what do I want to do? I want to update the unit price. So I want to update the unit price to, so I'm going to use a case statement. So case when name of the product is equal to, okay, let's copy it from the cursor query. When name is equal to product hyphen product dash 55, name of the product is equal to product 55, and we have copied that from cursor query. So if the name is product 55, then what we want to do? Then we want to update the unit price to 55. Along the same line, if the product name is 65, then we want to update the unit price to 65. And along the same line, when name, like if it start with product dash 100, then we want set the unit price to 1000. Okay, so that is our conditions. And then we basically want to end the case statement. Okay, so it is very simple case statement. We have discussed about case statement in the previous session of the video of this video series. If you have not watched that, I would strongly encourage you to do so. So we have that there, and in the where clause, we can specify what products we want to update. Since we now have access to the name column, we are using a join. We can also filter the rows. We don't want to retrieve all the 600,000 rows from TBL product sales table. You can filter them using the where clause. So I'm going to specify where name is equal to product dash 55, or let me copy that. Name is equal to product 65. Finally, name like product dash 100. Okay. So whatever rows match these conditions, criteria, retrieve them and update their unit price to 55 if the product name is 55, or 65, depending on these conditions. So let's go ahead and run this query and see how long is that going to take. Now remember, in the previous session it took around 1 minute 40 seconds to update, to process the row on a row by row basis using cursor. Let me execute this. Now look at this executing query. Executing query. And how many rows are? It took 0 second. You can see here it took 0 second. And how many rows are updated? 1643. Rows are updated. Now to check our result, we can make use of the same query that used in the previous session. So when I execute this query, execute this query, we should get all the rows and look at that whatever has. So let me execute it. And look at that, whatever has entered, name pattern product dash 100, and then anything after that, the unit price is updated to 1000. Name pattern product dash 100, and then anything after that, the unit price is updated to 1000. Let's check it for product 55 and 65. Look at that, product 55, all of them are updated to 55 and 65 are updated to 65. 65, 65, 55, 55. Okay, so the update query worked as expected. And look at this, the amount of performance. And look at this, the amount of performance, where is 0 second and where is 1 minute 40 second. There is drastic improvement performance, and that is because we are using joins. That is one thing. Joins work much better because they operate on rows on a sets basis. Okay, whatever rows meet these criteria, they are updated, in sets, rather than processing the rows, individually on a row by row basis. And another thing is, since we are using the where clause, and another thing is, since we are using the where clause, we are not retrieving 600,000 rows from TBL product sales. Instead, whatever rows matches whatever of the common rows between these two tables, and then we also have a where clause, so it reduces the rows to 1643. That is why this query is very fast. Okay, we can even remove this where clause. So if we remove this where clause, then what is going to happen? We get 600,000 records. Okay, but still, since we are using joins, it is going to be very fast, so. But then if I remove this where clause, then what is going to happen? We get 600,000 matching rows. So if we get 600,000 matching rows, look at this. You are saying set unit price. To 55 and name matches to product 55. Otherwise 65. Otherwise 1000. If the name product does not match to any of these rows, if the name product does not match to any of these rows, okay, then the unit price will be updated to null. And we want to avoid that, because since we don't use this, we get other, we are not using the where clause, we get the other rows as well. And if the name is not matching any of these three things, then we don't want the unit price to be updated to null. That is why what you do is have an else class. If the name does not match any of these three, then what I want back the unit price. So else class. If the name does not match any of these three, then what I want back the unit price. Just update with whatever unit price that is already there. Okay, but usually we don't do this because we already have access to the name column. As we are joining these two tables, we can simply filter the rows. But even if we don't filter, even if we are processing all the 600,000 rows, and I am doing that using a join, let us see how long is this query going to take. Okay, now when we execute this update query, it is going to update 600,000 records, because in TBL product sales we have 600,000 records, and there is matching rows for every row in TBL product sales. A matching rows is present in TBL products. That is why this is going to update 600,000 rows. Now let me go ahead and run this. Remove this first. We do not want to use the where clause. Now let me execute this. Look at that query executing. Now it is definitely going to be more than 0 second, so it is 2 seconds. Remember, the previous query using cursor took 1 minute 40 seconds, but look at this query completed successfully, and how long it took? Only 2 seconds. And how many rows have affected? 600,000 rows. Okay, though it is processing 600,000 rows, we still have the data processed in 2 seconds. But whereas when we do it with cursor using a row by row, when we processing rows on a row by row basis, it took around 1 minute 40 seconds. Okay, now let's quickly check if the data has been updated as we expect. Okay, so first I want to see for product 55 and product 65. Execute it. So that is the same 55, 65, 65. And let's check for the other thing where name pattern is product -100. So that is 1000. And let's check anything that does not match. These three things. That does not match these things, because we don't want that to be updated to null. So let me select top 10 star. Let me select top 10 star. Look at this for the other product. So execute this. Look at this for the other product. The unit price are same. They were not updated to null. They are not updated to null. Now whenever you don't have the where clause, make sure you have this else part. Otherwise, what is going to happen? If that condition is not matching, look at that. Look at what is going to happen if I execute this update query. Some of the row will not match these conditions. For all those rows, the unit price will become null because none of these conditions are met. So a null will be returned. So if I remove this and execute this, so make sure you have this else part. Otherwise, what is going to happen? If that condition is not matching, look at what is going to happen if I execute this update query. Some of the row will not match these conditions. For all those rows, the unit price will become null because none of these conditions are met. So none of these conditions are met. So a null will be returned and unit price will be updated to null. So let me execute this, as we have removed the else class or else part from this query now. So execute it. All these rows will work as expected for 55. They will be, for any product with product 100. So execute this. For any product with product 100, that is okay. And for 55 and 65, that is also okay. So all these rows will work as expected for 55. They will be. And for 100, product 100, we have showed that. Okay. And for product 55 and product 65, also it will be fine. Data will be fine, as you can see here. But check, top 10 maybe from product sales. But check top 10 maybe from product sales. Table check the unit price. So let me execute it. Look at here. Check the unit price. It will be null. And we don't want that to be happening. That is why whenever you use a case, statement and you are expecting rows that may not meet and you are expecting rows that may not meet this criteria, and if you want the data to be updated correctly, make sure you have your else part as well within the case statement. So when I execute this query, obviously you have seen that there is a drastic improvement in performance. Okay, so this can, you can imagine the amount of impact that cursor is having on performance. Performance, cursor should always be used as a last options. If you don't have any other way of achieving what you want to achieve, only then make use of cursors. Or if it is a throwaway script, you just want to run it one time, and if performance is really not a concern, maybe we can make use of cursor. But real-time production code, we know how bad cursors are for performance, though, so they should be avoided as much as we can. That's it for today. Thank you for listening. Have a nice day.